Hello. Now we are going to start machine learning, right? So first we'll discuss about the classical machine learning, right? Now, in this video, we'll see a basics course introductions, what the machine learning is, right? And why we need to use machine learning, right? And here in this course or in this video, right, we do not have to worry about the imports. Whatever the imports that we are seeing, right? We'll see each imports, right, where this particular imports is required over the period of the course or the video series. Now again, here we have this data directory, right? So what we'll see from this lecture, we'll see that what is the motivation behind studying the machine learning. Briefly, we'll introduce about the supervised machine learning. We'll see the differentiate between the traditional and the class and the machine learning, like how the traditional programming is different than the machine learning. And we'll assess whether the problem is suitable for machine learning solution or not, right? First, we'll see why machine learning. So, machine learning is a tool to build a programs. So, consider that your voice assistants in all these AI, this we call this as in small AI programs like the Alexa, Siri, Google Now, Cortana. All these are the small AI program in its own self, right? Basically, these program automatically understand, right? And you can say that way, these program has in rules to understand your voice command, and based on your voice command, it gives you the or it returns the out, right? We have this Google News then. So Google News is smart enough to recommend you the specific Google that you are interested in. Let's say that on an YouTube or the any other sources, right? If you are looking for the specific type of news, then the Google News will understand and it will recommend you the similar type of news. Let's say that if you have clicked the specific news, later on, if any such event happens related to that specific category, Google News will push that categorical news specifically to you, right? Then we have this recommended systems. So this recommended systems is also there with the Netflix, it is with the Amazon, it is with the LinkedIn. So Amazon will recommend you the specific item which you are looking for or which you have already searched for. Same as the LinkedIn work. Let's say that if I search for the specific this job in a job portal, then this LinkedIn will recommend you the similar type of job if any job comes in the future. And same way this Netflix work. Again, we have this face recognition system. This is a different AI. Voice assistance is a different type of AI. Google News is a different type of AI. Recommendation system is a different type of program. Face recognition is a different kind of program. It understands your face, right? It try to capture your face, and basically here we use face recognition mostly to unlock your phone, maybe your iPhone, right? Or maybe your vehicles, which kind of recognize your face, right? So face recognition also a type of AI. We have this auto completion system then, which auto complete the specific word. Then we have this a lot of AI like stock market predictions, character recognition. We have this drug discovery, cancer diagnosis, self-driving car. All these are the potential domain for the AI to grow, right? And all this is possible with the artificial intelligence and machine learning. Again, when I'm saying the word AI and the machine learning, so though AI is a very broader term, right? Whereas machine learning is a sub part of the AI, right? You can understand that one of the component to build an AI, right? But People use interchangeably the term. When people say AI, they are mostly kind of referencing to the machine learning and the deep learning things, right? Now, why machine learning? Because it saves times. It will help you to scale the products. Consider that, for example, consider that if you are building a spam detector, like a Gmail has a program to detect the spam, and it will specifically detect the spam and will learn the pattern of the spam message or the mail, and then it will push the spam mail to the spam category, right? And consider that if you have to write such kind of program, it will take a lot of time to understand the message. See, as a human to understand the spam mail, right? It's a little bit easier, but transforming our understanding to a usable code is a very hard. It's a very difficult problem. It's like you will have to set rules for every kind of small things. But machine learning works very differently than the traditional programming. Whereas you just need to collect the data of this two category like spam and non-spam, and then machine learning algorithm will figure it out the specific pattern between spam and non-spam mail, right? Whereas in the traditional programming you will have to write the rules, right? So with the machine learning, it's like once you know how the machine learning work, you just need to fetch or feel the large amount of data, and that's it. Machine learning will understand the pattern. It will write the program for you. You do not have to do that. And because it is manageable, it is a kind of building machine learning model is easy, right? With a good understanding, it is also scalable so that you can use that model for a various kind of products, right? So machine learning will help you to save a lot of times, right? Now let's talk about the supervised machine learning. But before that, let's see how many type of machine learning we have. Machine learning generally have the four category like supervised machine learning, unsupervised, reinforcement, and the recommendation. So the spam filtering or spam detection email that we just discussed about was an example of supervised machine learning. And then the Google News, recommending Google News that we discussed earlier, that was the example of unsupervised learning, right? We have not discussed the example of reinforcement learning, like AlphaGo. Over here, this was the example of reinforcement learning. The way it works as if an AI, it's like AI versus humans. If an AI achieve the goal, it will get the it will get the reward. And if it fails, it will get the kind of so the drawback is it will get the minus point, right? So and AI has a basically we set AI in a such a way that your task is to achieve the maximum rewards, right? So that is a task of that is how the reinforcement learning work. Then the recommendation systems. Basically, we just discussed about this Netflix and the Amazon. They works as a recommendation systems technique, right? So they all are implemented as a recommendation system. So all these are like the Amazon or the Netflix or the LinkedIn, all these platforms uses this recommendation system techniques, right? But so what is supervised machine learning then? So we just discussed about the examples of all the different type of machine learning algorithms. So in supervised machine learning, training data, we all know that machine learning needs the training data. So training data needs to have the two part in it. it needs to have the X part and the Y part. What is the X part? X part is the observations and the Y part is the targets. So what is the observations and what is the target? So consider these examples over here. Here consider that we want to classify, we want to build a machine learning model to understand the dog and the cat emojis, right? We have this example as an cat images and the dog images, right? So this exact data, this emojis becomes the X part of the data, and then this Y part, which says that this is an cat emojis and this is an dog emojis. This part is it's like it will give you the information about the emojis. This is the Y part of the data, right? So in supervised machine learning, you need to have both part, X and the Y both, right? So and so this X and the Y both includes, combines, and then becomes a training data. Now here in supervised machine learning, we want to find a model or a function. Let's call that function f that relate x to y. So we want to find a function which have the relationship between x and the y, right? So here again, consider that if you have to write your own program to get the relationship between x and the y, how would you build that? Now we have to write some logic to make sure that this image or this emoticons belongs to the cat and this emoticons belongs to the dog. We have to write some functions, right, which specific, some logic which specific about the cat emoticons and the dog emojis, right? And that logic is what the model function is. So here with the machine learning, we'll pass this x and the y data, we'll pass this entire training data, and then we say the machine learning that please find the pattern in the data which define cat and the dog, like which pattern defines cat and the which pattern defines dog. And then later on, like over here, we can see that we are passing this training data, we can see this picture to this learning algorithms. So what is learning algorithm? So learning algorithm is one thing that we are going to learn. So basically in machine learning, there are different type of machine learning algorithms. Those are called learning algorithm, right? Like the linear regression, logistic regression, KNN, neural network, SVM, all these are the learning algorithms, right? So in machine learning, we just will understand in this class, we'll understand what are those learning algorithms and will kind of understood how to use those learning algorithms, how those learning algorithm works, right? So we'll pass this data to the learning algorithms, and then this learning algorithm will return you the learned function. It will return you the learned function f, and in machine learning domain we call this as a model. So it will return you the ML model. Then we want to use this ML model on unseen data set. Let's say that we have the new emojis now, which is the emoji. So it's when I'm saying new, it's like a new data point, so a new example. It's not like emojis from the different background, right? So remember that if your data training data contains the emojis about cat and dog, you cannot pass a human emojis and hope that it will identify the human, because your learning algorithm does have not seen these human emoticons. It has only seen this cat and dog emoticons, and it will only understand this cat and dog emoticons, right? Now when we pass this cat and or like these emoticons, which is a new, which was not there into the training data, it is still the cat and dog emoticons, but it was not there into the training data, then this machine learning algorithm is able to detect the correct emoticons, right? It is able to detect that this is a cat and this is a dog. Then it is a perfect machine learning algorithm, and we call this as an predictions. So here we have this training data. We pass this training data to the learning algorithm. Learning algorithm will return you the ML model. Now we can use this ML model to predict on the unseen data set. Here we have this unseen data set. We'll use this learning algorithm and pass to the unseen data set. So we'll take this unseen data set and pass to the learning algorithm, and that will return you the predictions, right? So this is how machine learning works, right? And we usually want to try a machine learning algorithm, the new examples, but we train the machine learning algorithm on a different example, but again the similar example, not different. Then does not means it's entirely different. It's a similar data points, but not the exact data points, right? So that is how a supervised machine learning work. Example is predict whether the spam message is spam or not, right? Here in this we need to have the two type, because this is a, because here we want to use the supervised machine learning. We want to, so in the input feature we'll have X and the target is our Y. So X is also called the input features, right? So here we have the code. Again, don't worry about the code, right? For now we'll understand about the code later in the course, but this is just for the information, right? Here we have just uh, downloaded and then displayed this some messages, right? This is the messages we have, and this is the target value we have. So here we are separating X and the Y. You can see that this is the training and the test data we have. Here is the model we are building, and then we are applying. When we say clf.fit, this means that we want to train the model. Again I'm saying don't worry about the code, right? But just see that here we have written the code, just 4 lines of code, and we can see that model has, so this was our test data. This is our test data now, and now we want to predict the output of the test data. So this is how the model has predicted. Model has predicted this is a ham. Ham means it's not spam, and this is a spam, right? So a supervised machine learning has also popular definitions, a lot of definition it has, right? In 1959, author has given the definition for this. It says that it's a field of study that gives computer the ability to learn without being explicitly programmed. So here we do not have to program the code. We do not have to write the program, but this program is being written automatically, right? So that is what a supervised machine learning is, or a machine learning is in general, right? So ML is different way to think about problem solving, right? So consider that this problem we have here, the example is, so this is the problem we have, given the number n and a program to calculate square root using Newton-Raphson method or NR method, and we have to output the square root of n. So we have to write a simple program with the n given that calculate the square root of that number and return the square root. So what is the traditional programming approach is? So we want to write a program, right? So here we'll write a program, and that program needs the input and return the output, which is the square root of number. So this is how, so we have to write the program by our own self. We have to write the logic of square root, right? But let's say that, how is the machine learning approach? So in the machine learning, if you'll solve this entire problem with the machine learning, what you need is, you need to give the data set containing, like here is a different examples we have, but consider that if you want to solve the same examples with the machine learning, what you'll do is you will give a data set containing the n and the square root of n. Then you pass that data set, and then machine learning will return you the program. So basically in the data set we have the input and we have the output both, right? We have the n and then we have the square root of n. and then the output would be the program. This is a machine learning approach. Here is a different examples of machine learning is given a data set containing image of the cat and the dog and their labels. So we have the data, which is the images of cat and the dog, and we also have the label, which is output. And then as an so the output is also there, right? And now this machine learning will return you the program which will help you to whether this to predict whether this image is a cat and the dog, right? So it's a very different approach to solve the problem, right? Now let's look at some of the concrete example of supervised machine learning. Again, don't worry about the code right now. So here the example is we want to predict whether the patient has a liver disease or not. So first, so here because we have this, we want to write a program whether this particular patient has liver disease or not. So first we need to collect the data point of all the parameter, and then we have to set that whether this with these parameter if the person has liver disease or not, right? So here we'll not only collect the data point will belonging to the liver disease, we'll also collect the data point belonging to the patient who does not have the liver disease, right? So we want both type of data over here. So here we are reading the data. Here you can see that these are the parameters. Based on this parameter, doctor decide whether this is liver disease or not. Here we can see that as a target we have this disease, no disease, right? So if there is no disease, that means with these parameter person does not have the liver disease. When you see disease, this means that with these type of parameter person does have the disease, right? So this is the data we have. So now we have the data ready. Now we want to build supervised machine learning model. So when I'm saying building a supervised machine learning model, this means that we want to learn the functions which have the understanding of these two types, disease and no disease. So it will understand that based on these input, it will ask this input, right? This model will ask this input, and based on this input, it will kind of return whether this person has a disease or not disease. So it will learn these patterns. You do not have to write program for this to understanding this. That is how the supervised machine learning work, right? So here we are training our model, right? Again, don't worry about the code, right? Here we are separating the training part of the data and the test part of the data. So the test part of the data will help you to test how this model is performing, right? And this is the model and this is the training happens, right? And here, and after that, we have just checked the test data set. Here we have just printing the test data set, and now we'll pass this test data set, and here we'll see that what is the predicted output we have. So this is the predicted target we have. That is, this is how the model. So these are the value that model has predicted. It has predicted for these first persons has no disease, all the person had disease, right? Now in the example 2, we'll talk about predicting labels of a given image, right? So suppose, so this is one image, this is the one type of problem we are solving. This is another type of problem we are solving, right? Now let's try to see how this image classification work, right? We want to predict whether this particular image, or like we want to label this image, what this image is all about. And here we can see that we are solving the problem. Like it says that it is a 63% that it's a tiger cat, it's a 17% that it's a tabby cat, and so on. Here you will see the output in terms of percentage for all the examples. This is a different type of problem that we are solving, right? Now let's see a different example like predicting sentiment. Again, don't worry about the code. As I'm saying, just right now just familiarize yourself with the what the machine learning can do, right? Here is a third examples we have. We want to predict the sentiment in a movie review. So here we have this review, and then this review has a sentiment that this review is a positive review, this review is the positive review, this is the negative review, and so on, right? Now we want to understand this text, and based on this text we want to predict what is the sentiment for this text. Like, so basically our program has to understand the pattern of the text data. Then only it will kind of give you the sentiment, right? As a human being, we also read the sentiment. By reading it, will just understand that this is giving us signals of the negative uh, kind of uh, kind of sentiment, right? And we also decide this negative and the positive sentiment based on the words being used into the language, right? So machine learning will also use the similar technique. It will see based on which word is being used, and then it will decide that this word is being used a lot into the negative kind of comments, and these words is being used more on the positive comments, and based on that it will decide, right? And here we have separated X and the this training and the testing data. Again, why do we need train and test data? So we need train and test data so that we can use the training data to train the model, and then we can use the test data to test the model. Here, when I'm saying model, this means that I'm talking about the functions. Right? And again, we are writing the functions. Here we are trying to predict the output, and this is the predicted value we have for the specific sentiment. Right? Now let's talk about the fourth examples. Here we want to predict the housing price. Right? Here we want to predict based on the house attributes. We want to predict what is the price of the house. So our target is this, which is the house price, and these are the attributes. These are the features we have. These are the features or the attributes, right? Both are same things. Based on these features or the attributes, right? We want to decide the price of the house, like based on how many number of bathroom we have, how many number of bedroom we have, what is the square foot livings, what is the square foot lot area, how many number of floor we have, do we have the waterfront or not. All these parameters sets the house price, right? And we want to use the same parameter, but again we do not want to write a program by our own self. We want to write a programs using machine learning algorithms, right? So here we are using this machine learning, and by writing the programs, and here we can see the predicted value we have, right? So as in summary, machine learning can be used to solve this variety of problems and the different kinds of data, right? At this point, we want to understand that how we exactly learning whether this message is spam or not, like how this algorithms is being understanding the patterns of message with the whether this message is spam or not, right? And again, when I'm saying machine learning learns the patterns, so here we are saying that what do you mean by learning patterns without being explicitly programs? That means, of course, like when we write the program, right? So we are familiar with that. If the program is there, then there is a code somewhere, right? So where that specific logic or the code is being written, this is at this moment, these are the questions comes in the mind for the first time or for the beginner learners, right? And the question is, are we expected to get the correct predictions for all the possible message or not? Right? Like how does it perfect the how does it predict the label for message it has not seen? Because we use the training data, and based on the training data we understand the patterns, and because we have used the training data, so the let's say that your model, your machine learning has understood the patterns of the training data, and then it will give you correct output for the training data. But how about the output for the data which has not seen, which was there on the test data? So we always use test data to predict the models. So to predict the output of the new examples, right? And to test the models. So how does that work? And what happens if the model mislabel the unseen examples? How do we correct that? How do we measure the success or the failure of the spam identification or any type of problems? How do we measure how, like, because we are not building the machine learning models, how do we measure whether this model is correct or not, and how much it is correct, right? And again, if you want to use that model into the kind of real life, is it reliable or not? So there are a lot of questions we have, right? We'll see that. We'll kind of discuss those things, right? Again, all these questions will be revealed throughout this entire series, right? Now this machine learning workflow. So now we'll discuss how this machine learning workflow is. So machine learning is very flexible. So our first task is we want to do the data collections. And after that, we want to do data cleaning and splitting. We have already discussed about the splitting, right? We split the data into the training and the test part. But before that, sometimes we also need to do the clean the data. Then we need to do the data explorations. After that, we'll do the pre-processing and the feature engineering. Then we'll do the feature selections. Then we'll do the model selection and the evaluations. And then after we'll deploy the model and then we'll test it, right? So there are a lot of there's this lot of jargons we have to understand this entire supervised or any machine learning task, right? What is this, right? So as in summary, what we have seen till now, we have seen as machine learning is being applied in a various field. We have seen that it can be used into the various field, right? In supervised machine learning, specifically, we are given the observation which is x and the target which is y, and then we want to find the model function f which relates x to y, right? Machine learning is a different way of solving problems, right? And it reduces this entire like a time on spending this programming task, right? So it will help you to reduce a lot of times. And before we applying machine learning problems, right? We first need to understand whether this problem is suitable for machine learning task or not, or we have to make our problem suitable for machine learning if you want to solve that way, right? So this is what a basic introduction to machine learning we have discussed, right? And later on, so in the next course, we'll start talking about what is supervised machine learning in more details, right? For now, thank you very much.